Can a system like this really produce and control energy for your home in real conditions? Today, I will install everything step by step and test it using real measurements. Let's start by unboxing the SolarFlow 800 Plus. This unit is compact and relatively lightweight. The design is clean and built for practical home integration. It features 4 solar input ports, allowing flexible panel configuration. This is the AC connection port for grid integration. The front display provides real-time system information, along with a simple power control button. These are the included accessories and connection cables. Now let's move to the installation and real testing. I'll mount the unit to prepare it for installation. The system provides multiple input ports for solar connection. I'm installing dedicated DC breakers for safety and control. I'm using 2 solar panels, each rated at 450 watts. Let's measure the voltage output from each panel. Now connecting the panels through the breakers for controlled input. Now let's take a look at the Zendure 3CT smart meter. This is the smart meter along with the current sensors and connection cables. These current clamps are used to measure real-time energy flow across each phase. The meter is designed to monitor power consumption and direction in real time. It supports 3-phase measurement for more accurate and complete data. This data will be used by the system to optimize energy usage automatically. Now let's install it and see how the system behaves in real conditions. Now connecting the system to the grid. As soon as it's connected, the system reacts in less than 3 seconds. You need to register and log into the application. Once logged in, you can access and manage your devices. The app will scan for available devices nearby. The SolarFlow 800 Plus appears in the device list. You can connect using either Wi-Fi or Bluetooth depending on your setup. In this case, I'll use Wi-Fi for a more stable connection. I'll connect the system to the network and complete the setup process. The system is now connected and ready for control. The Zendure 3CT smart meter is also detected. You can connect using either Wi-Fi or Bluetooth depending on your setup. I'll connect the system to the network and complete the setup process. The system is now connected and ready for control. Now we can monitor and control everything in real time. Now I'll switch on the solar input. As you can see, the panels are now generating power in real time. The total input is around 537 watts, with each panel producing about 260 watts. To verify the measurement, I'm using a clamp meter on the input cable. It shows around 8 amps flowing into the system, which aligns with the real-time power reading in the app. Now I'm switching to Zenki mode. This mode automatically adjusts energy flow in real time. I'll apply a load of around 700 watts. As you can see, the system responds and starts supplying the demand, reducing grid consumption. This is the Smart Meter 3CT interface, displaying real-time energy flow and total power in the system. You can also monitor how the load is distributed across each phase. Now I'll increase the load to around 1500 watts. This exceeds the system's maximum output. As expected, the system delivers up to its limit, and the grid supplies the remaining power. Now I'm switching to auto mode. This mode keeps the system operating in a stable and controlled way. With a load of around 1500 watts, the system delivers up to its limit and the grid supplies the rest. Now I'm switching to smart meter mode. In this mode, the system relies on real-time measurements from the smart meter to adjust energy flow more precisely. This provides a more realistic view of how energy is used in the system. The system allows different charging strategies, including price-based, scheduled, or surplus energy charging. I'll focus on surplus energy charging, where excess solar power is stored instead of being sent to the grid. This is the Smart Meter 3CT interface, displaying real-time energy flow and total power in the system. You can also monitor how the load is distributed across each phase. Now I'll begin by selecting base load mode. Then I set the operating time period. Next, I choose between charging or discharging mode. Finally, I can adjust the output power from 0 up to 800 watts. This allows flexible and precise control over the system behavior. Here, the system is operating under real conditions. The battery is charging, the load is running, and the solar panels are generating power. All of this is managed simultaneously in real time. While staying in the same mode, I set the operating time period. Then I select discharge mode and adjust the output power from 0 up to 800 watts. This means the system will supply power to the load during this period. In this test, the system is set to maximum discharge at 800 watts. After around 14 minutes, the battery level decreases by about 10%, showing real energy usage under load. In the battery settings, I can define the protection limits, set a minimum level to stop discharging, and a maximum level to stop charging. This helps preserve battery health and extend its lifespan. I'd also like to highlight that the SF800 Plus is the best value option in the series. If you're looking for a reliable entry-level energy storage solution that doesn't break the bank, this is it. You get Zendure's top-tier build quality and app control for a fraction of the price. It's one of the fastest and easiest ways to see a return on your investment, especially recommended for beginners in balcony solar systems.